Next up, we have the terms increasing and decreasing. So what do they mean, and how do we define them mathematically? So the mathematical definitions for increasing is the following. F of x is called increasing if for every a that's less than b, the f of a will be less than the f of b. And also, we say that the g function is decreasing if for every a that's less than b, the g of a is greater than the g of b. Okay, so these are technical terms, but they don't have to be complicated. They don't have to be very difficult. You can read the terms and definitions in words. It says if the input A is less than the input B, then the output for A is going to be less than the output for B, then the function is decreasing. So in other terms, if you think of a function like this blue one over here on the side, that function is known to be increasing. How do we know that? Well, if I take an A that's on the left side of a second number B, I'll notice that the y-coordinate of A is actually less than the y-coordinate of the value B. So another way to think about it is like this. Suppose that you have a little stick figure guy, and the stick figure guy is walking from right to left on this graph. My little stick figure guy would have to go uphill. So therefore, we say that the function is increasing. So your little guy is always walking from left to right. Now, on the other hand, how do we know that the function is decreasing? So that's what's going on in the second graph on this page. Well, again, the way it works is we pick a number A and a second number B to the right of it. And then we look at the y-coordinate of A, we look at the y-coordinate of B. If the y-coordinate for B is always smaller than the y-coordinate of A, then we say that the function is decreasing. In this case, if I put a little stick figure guy on the graph and I make the little stick figure person walk from left to right, I'll notice that the stick figure is going to be going downhill. So therefore, we say the function is decreasing. And in words, to say that something is decreasing means that the input A, which is less than the input of B, will result in an output for A that is greater than the output for B. So in that case, we say the function is decreasing. So those definitions are great and everything, but they're hard and difficult to use in reality. So instead, we will look at this theorem over here, which says the following. It says, if the derivative f prime of x is greater than 0 for all x's in an open interval, then we say that the function is increasing over that interval. And also, if the derivative is less than 0, we say that the function is decreasing over the interval. So in other terms, this gives us a recipe and a way to find whether the function is increasing or decreasing by just looking at the derivative. Find the derivative. If the derivative is positive, you're increasing. If the derivative is negative, you're decreasing. Let's demonstrate with example number 2. This, by the way, has the same function from the last example, so we can use the derivative and the critical values and everything. So I'm going to start with that. It says in part 1, list the open intervals on which the function is increasing. Then it tells me to do part 2 and find the intervals on which the function is decreasing. So let's start with the increasing intervals. So again, the way I'm going to have to do it is first start with the function, then find the derivative, then find the critical numbers or values. So I'm just going to copy the derivative from the last example, which was 6 times x minus 2 times x plus 1, and then I'm going to recall that the critical values are 2 and negative 1. So that's the start of every problem that we do from pretty much this point on. The next step in the process is to draw a horizontal line that will represent all the numbers in the world. So I'm going to put negative infinity and positive infinity. And I'm going to place my critical values, which are 2 and negative 1, on this line. So those critical numbers have to be put in order. So I'm going to put negative 1 first and then also the 2. So those are the critical values or the critical numbers that we got from doing the derivative and setting it equal to 0 and finding what makes it undefined. Once you do this, the next step is going to be what's called testing. So what we're going to do is we're going to pick a number from the interval negative infinity to negative 1. So pick any number you want between negative infinity and negative 1. You're just not allowed to pick those two, negative infinity and negative 1. So like, for example, negative 10 would work, negative 5 would work, negative 17 would work, whatever. Just pick a random number and eventually that number will be erased. the next step is going to be to pick a number between -1 and 2. So again, we pick a second value and we test. So I need a number between -1 and 2, and again, I can choose anything between the two numbers, including decimals, periods, whatever, but I cannot choose -1 itself or 2 itself. So I'm going to pick 0 this time. Then finally, again, repeat the same procedure between 2 and positive infinity. So pick any random number there. I'm going to pick the number 10. Now, this is called the first derivative test. So I'm going to put f prime of x on the side over here, because we will have something similar going on when we get to the second derivative, and the result that we get there is going to mean something different on the graph. So make sure you label the line with f prime or f double prime depending on what you're doing. So once you have picked the test values, your job now is going to be the following. Take the numbers that you just decided to test and put them into the derivative. So you can put them into this equation or that equation. It's up to you, whichever one you want, but just put them into one of those equations, and we want to investigate if the answer is going to be positive or negative at the end. So like for example, if I put -10 into the second version, x minus 2, then x plus 1. So I'm going to erase the x's basically and replace them with -10. That was my test value. What would the result be? Would it be a positive value or a negative value? So let's see, I have 6 in front, then I have -12, then I have -9. If I were to multiply those numbers, my final answer would be a positive value. So that's the only thing I'm going to pay attention to. That plus sign is what matters to me. So I'm just going to put a plus right there where the -10 was found. So -10 gives me a positive result. Then repeat the same thing again with 0. Okay, so 6 times 0 minus 2, and then 0 plus 1. So the 6 on the outside is going to stay. 0 minus 2 is going to be -2, and 0 plus 1 is going to be positive 1 at the end. So when you multiply 6 with -2 with 1, what's the answer going to be? Turns out that the answer is going to be a negative amount. It's actually -12, but I don't care about the 12. I just care that it was a negative amount. So I'm going to put the negative in the middle interval because 0 gave me the negative result. Then finally, we'll do the same thing again with the 10. And as you can see again, we get a positive solution. So this is a positive answer. So the 10 gives me a positive answer. So at this point in time, you can pretty much get rid of all of this work because this could be done on a calculator. So I don't necessarily want to see it, or you don't have to demonstrate it. And you can also kill off the test values that you decided to choose. So I'm just gonna write erase, and I'm not going to erase them just in case somebody wants to see them. But in typical situations, we would just get rid of them completely. Now, the final thing we have to do is decide where the function is increasing, where the function is decreasing. And this is the fun part. All we have to do is look at the interval that we just drew, that line that we drew, and figure out where the pluses were. There was a plus between -infinity and -1, so that means that's the place where the function is going to be increasing, because the derivative there is positive. That's why the plus sign. And also, from 2 all the way to infinity, there was a plus sign, which means that the derivative again is positive, which means the function is increasing according to the theorem that we have on top of the page. So we can say f of x is increasing on the interval from -infinity to -1, and also from 2 to infinity. So now some notation. First of all, infinity always gets parentheses next to it. Whether it's positive or negative, it doesn't matter. We put parentheses. The parentheses in this case means that we cannot include that value. Remember, there's no largest number or smallest number, so that's why we can never get there. So that's why we put parentheses. And also the -1 and the 2 get parentheses in this case. That's because they said open interval. They wanted open interval, that means they wanted parentheses around everything, not brackets. And then finally, because there are two solutions and they both work, I'm going to put the union sign in the middle. So that means that you can take the first one or the second one, and they both are going to be good solutions. And that's the end of part 1, which says, tell me where the function is increasing. Now for part 2, I actually do not have to do any work. It says, tell me the function's intervals where it's decreasing. So all I have to do really is look at that same line and decide that it's negative between -1 and 2. So that means the derivative is negative there. That means the function is going to be decreasing. So that's very straightforward. All I have to do is write down that the f of x is decreasing on the interval from -1 all the way to 2. Again, it's open interval, so that's why we're putting parentheses. They said the word open up in the question. So as you can see, the work is the same for part 1 and part 2. So typically speaking, we combine those two parts of the problem in one question. We just say, tell me the intervals on which the function is increasing or decreasing, because the work is identical. So in this case, don't write it twice. Just write it down once and then use that line with the green and orange to get the two solutions of the problem.